Hello everyone. Have you ever wondered how your family tree, folder structures in your computer, or even AI decision making works? Well, they all rely on one fundamental data structure, trees. In this video, we will break down the trees in a simplest way possible with real life examples and easy explanations. So let's start. As we understood from the video, tree is a non-linear data structure used to represent hierarchical relationships. For example, family tree, folder structure in our computer, etc. Tree is a non-linear data structure because one element of the tree can be connected to the multiple elements of the tree. It consists of nodes connected by edges. So the element in a tree is also known as node, and the two nodes can be connected by edge. Each node can have multiple children, but it can have only one parent, except the root node. Root node is the topmost element of the tree from which tree starts. It does not have any parent. If you want to represent the parent-child relationship, if this node is a parent, then the node connected down to that node are known as the child nodes. Similarly, if these are the parent nodes, then these are the respective child nodes. And the child nodes which does not have any other child nodes, they are called as the leaf nodes. So the nodes does not have any children, they are known as the leaf nodes. Let's understand the different base types of trees. First is general tree, a tree where each node can have any number of children. It is a base structure on top of which all other tree types are built. The real life example of general tree is organization hierarchy, where you can see one CEO can have multiple managers, each manager can have multiple employees. So any node can have any number of children. Next type of the tree is binary tree, a tree where each node has at most two children, left and right. So if you see this example, each node have at most two children. Here start node have yes or no, yes node have A, B. Binary trees are useful in cases where decision making is required. For example, game where it asks us the different questions, and when, based on our answers like yes or no, it then gives us the next steps in the game. Next type of the tree is binary search tree. It is a binary tree where left child nodes have smaller values and the right child nodes have larger values than the current node. For each node in this tree, if you see, let's say for example this node, all the nodes on the left of this node have smaller values, and all the nodes on the right side have the larger values than 50, and it is true for each node. Binary search tree are useful in a cases for fast retrieval, efficient searching, like database indexing. The next type of the tree is balanced tree. It maintains the balance to ensure the optimized search, insertion, and deletion multiple times. Basically, try to keep the overall tree height minimal. So the tree height means the longest path from root node to the leaf node. For example, if we have this folder structure like this, file.txt is stored in so much hierarchy, then it becomes inefficient to get the file.txt. But if we balance this structure like this, then the file.txt retrieval becomes fast because the height from root to the subfolder till the file is more than compared to here, right? So the balanced trees help in such cases. So our folder structure in a computer is good example of balanced tree. Next type of tree is a heap. It is a complete binary tree where parent node is always smaller or larger than its children, all of its children. So there are two types of heaps. One is min heap and one is max heap. The heap type of trees are useful in a scenarios like priority queues. For example, if you see here, the priority queues are used in CPU task scheduling. Right? The highest priority task comes to the top, and CPU picks up this task, and then the next task, whichever the next has priority, come to the top. Right? That adjustment happens into the heap tree. Next type of the tree is a trie. A tree used for storing strings efficiently where each level represents a character in the word. For example, if you see that for a cat word, CAT are stored as a different node. Right? These types of trees are useful in a scenario like auto suggestion. When we type on Google or YouTube for search anything, right, you can see suggestions comes automatically, right? Let's say if we type CA, automatically CAT cat will come, right? And not only characters, we can store the string also as a node value depending on the use cases. Then the graph representation as trees. So representing part of the graph as a tree for use cases like finding the shortest path. For example, when we use a Google map, we can see the roads are connected like each other, like a graph, right? But when we want to find the shortest path from source to destination, internally that graph is represented as a tree to find the shortest path starting from the start point to the end point. So let's understand the binary tree implementation. So we'll understand the simple binary tree implementation just to understand the tree structure. So the major insertion deletion operation for each tree type we'll cover in the upcoming videos. So the binary tree implementation in a Java can be represented like a class node where we can store the key data. It can be int, char, string based on our requirement. And then we will have a left and right reference pointer, basically the reference object to the node, because it's a binary tree which will have two child, left and right. So the node structure is represented like this, right? So the node will store the key and it will also store the left and right pointer to the children nodes. Let's understand the implementation. So class binary tree, here in the constructor it is root is initialized to null, and when we create the object it is null initially. Then we create a new node and assign to the root, so the root will become the reference node of value 1. And then when we insert the left and right children for this node 1, then the tree will become like this, right? And then when we insert the left and right for the node 2, then the tree will become like this, right? So you can see the node structure and the left and right reference to the next node object. Some of the binary trees are also implemented as array. For example, this binary tree can also be represented as array like this, right? And these are the indexes. So depending on the use cases and type of the tree, binary tree can be implemented in an array also for fast performance. So for node at index I, which is this red one, the left child will be stored at index 2 into I plus 1, and the right child will be stored at index 2 into I plus 2. For example, for a node at index 1, which is 2, the left is at index based on this formula is 3, which is value at index 3 is 4, right? So the left is 4 for node 2, and the right is at index 4 based on this formula. I is 1 here. So the value at index 4 is 5. So you can see the for node 2, the left and right are stored into the, let's say the index is I for node 2. Left is at 2 into I plus 1 and right is at 2 into I plus 2. Let's understand the implementation of the binary tree using the array. So here simple class where tree is declared as a integer array with some fixed size, and then it has some function to set the root at the 0th index, and then it has a set left which computes the left child index using the 2 into parent index plus 1 formula, and then assign that new value to the left child index. Similarly, in a set right, it is computing the right child index and then assigning the new value to that right child index for this parent index. So similarly, when we try to do set root, initially it will create a node 1 at 0th index. And for the 0th index node, it will add the 2 value in the left side and the 3 value at the right side using this index calculation for left and right. And it will give the same tree as we saw in the previous slides. So this was the basic implementation of binary tree using a class and array just to understand the tree structure. So we covered the overview of tree using a real life example. Then we understood the definition of different types of trees and in which real life scenarios they are used. And then we understood the simple Java implementation, class based and array based, to just understand the tree structure. So hope you understood the video, and this will act as a base knowledge for the upcoming videos. If you like the video, please share and subscribe. Thank you so much.